Hello everyone, welcome to watch our video. We are going today to define the fundamental theorem of calculus, which show us how to find the definite integral on a closed interval analytically. Okay, let's define the concept of this theorem. Okay, wait. Yes. Here, if a function f is continuous, this means it has no gap, no any interruption in the curve of the function on a closed interval a and b. And capital F is an antiderivative of function f on the closed interval from a to b. Then the definite integral of function f of x with respect to x from a to b, it will be the antiderivative of the integrand function or the given function at the upper limit of the integration minus the antiderivative at the lower limit of integration. Let's show you how we find the definite integral by applying the fundamental theorem. Okay, look here how to find the definite integral of this function 6x with respect to x from 0 to 2. I had to find the antiderivative of the integrand function. It will be 6x squared by applying the power rule of integration. Look here, x to power n with respect to x. It will be x to power n plus 1 over the new exponent plus constant c, which is the constant of integration. But this one, if we are talking about the indefinite integral. But in the case of the definite integral, I don't have capital C. Okay, from 0 to 2. Okay, sorry, I increase over 2. It must be written in the simplest form. Okay, it will be 3x squared from 0 to 2. Replaced by the upper limit of the integration, so it will be 3 2 to power 2 minus, after we replace the by the lower limit of integration, it will be 3 multiply 0 to power 2. So your answer, it will be 3 multiply 4, it will be 12. Don't forget, I have to replace by the upper limit first in the antiderivative, okay, minus the value of the antiderivative at the lower limit of integration. Let's solve the next problem. Look here how to find this one. Some of you can find the antiderivative at the right of your copybook to be ready. Okay, here it will be what is the antiderivative? It will be t. I applied the power rule of integration here to power 3 over 3. Don't forget, increase the exponent by 1, then divide by the new exponent, minus, that is the constant rule of integration, to t, that is the antiderivative or the integration of this function, then from -1 to 1. In this case, we have to replace by the upper limit here between two brackets, okay, minus the value of the antiderivative at the lower limit of integration. Here it will be third minus 2 multiply 1, it will be -2. Okay, if we replace by -1, it will be -1 all to power 3 over 3 minus 2 multiply -1. Okay, here it will be, okay, by using the calculator, you will find the answer. It will be the final answer, sorry, -10 over 3. Use your calculator, find the answer of the first bracket, then the answer of the second bracket. So the answer of the first bracket minus the answer of the second bracket. Okay, let's continue the solution of this sheet as you see here. But I need the skills, as you know, I need the skills of memorizing the rules of integration, okay, and how to find the value of the function at any value. Okay, to solve this one, I have to find the integration of this function by applying the rule of integration. What is the integration of 1? It is a constant. It will be x. The variable that I find the integration with respect to x. Here sine x, its integration is what? Cosine x. But since the integration of the function, it has a particle, so it has a negative sign. Okay, this one from what to what? From 0 to pi. Okay, so I have to substitute by the upper limit of the integration in this antiderivative of this function. It will be, okay, replace here, it will be pi minus cosine pi. Okay, minus replaced by the lower limit in the antiderivative, it will be what? 0 minus cosine 0. Be careful if you use the angle in pi. This means I use the calculator in radian mode. By press what? Shift, okay, mode 3. Okay, to be in region, and in this case substitute by the value of pi. Here I keep pi here, minus cosine pi, it will be -1. Okay, minus, okay, 0 minus cosine 0, which is 1, minus -1. This one, it will be 0 minus -1. You can use your calculator. It will be pi plus 1 plus 1. It will be pi plus 2. How we get it? Here I can use the calculator in region mode, shift mode 3. In this case, replace cosine pi and enter pi by using your calculator. Or you can use in degree mode, that is region mode. In degree mode, shift mode 4. The angle must be entered in the mode of your calculator. Pi here in degree. Okay, if the angle, okay, in pi, I have to use radian mode in your calculator. I think all of you learned this one in the previous years. Okay, so the answer, it will be pi plus 2. Okay, make sure that your calculator in the same mode as you enter the angle. Okay, find the value here by using calculator. It will be pi, this one, minus cosine pi. I know pi in region, it means 180 degree. It means here, or cosine 180 degree. But if you enter the angle in degree, your calculator, it must be in degree mode. Here in this one, what is the integration of this function? The definite integration by using fundamental theorem. I have to find the integration of this function, which means the antiderivative. It will be tan x. Then substitute by the up from -pi/6, which means in radian. I can write it in degree, which means I know between two brackets, it means 30 degree. -30 degree. Okay, because pi in region, it means 180 in degree. Divide 6, it will be 30. By anyway, here pi/6, I know pi/6, it means 30 in degree. Okay, now it will be tan. Okay, if your calculator in region mode, you can write pi over 6. Okay, minus tan negative pi over 6 if your calculator in region. If it is in degree, you can enter what? 30 degree. It will be 2 root 3 by using your calculator over 3. I think it's so trivial. Just find the derivative of, the integration of the function, then replace by the upper limit minus the value of the function if we replace by the lower limit. I think it's so trivial and a very interesting lesson. Let's continue the answer of this sheet. Okay. Here, this problem. What is the antiderivative of the integration of this function by applying the rule of integration? Here I will apply what? The power rule and the constant which multiply any function. What is the integration here? It will be negative 3 multiply the integration v squared over 2. Don't forget I have to divide by the new exponent. Constant plus 4v. Don't say x because the variable that we integrate with respect to x here is what? V. Okay? From 2 to 5. I have to replace by the upper limit minus replacing by the lower limit. It will be what? Negative 3 multiply 5 to power 2 over 2. I think all of us became old enough to know how to substitute. 4 multiply 5, okay, that is 4, the first value, minus the value of the antiderivative at the lower limit. Negative 3 multiply 2 to power 2 over 2 plus 4 multiply 2. Use your calculator and find the answer. You can find the value of the first bracket, then the value of the second bracket, okay, and you can enter this expression in your calculator, but take care of the braces, okay, or the bracket. It will be what? Negative 19.5. So trivial. Okay, let's continue the answer of the sheet for question number 2. I think it's so trivial. Just apply power rule here. That is a constant rule. Then substitute by the upper limit the value of the antiderivative at the lower upper minus the value of the antiderivative at the lower limit of integration. I think it's so trivial and you can solve it alone. Okay. Look here. Let's solve this kind of exercise. Okay. Here for this problem. I told you before, sometimes the function not given in the form, okay, to apply the rule of integration, or it is not ready for the integration. So I need to rewrite the function. Let's see how to rewrite this function. This function, it is in radical form, and I can't apply the rule of integration on a radical function. It must be written to be in power form. Cubic root of t, it means t to power third. To power what? Third. Now it is ready to apply the integration rule. In this case, look here. I have to add 1 to the exponent, which will be 4 over 3. Divide any fraction. I have to divide by this new exponent. But as you know, divide any fraction, it equivalents to what? Multiply its what? Reciprocal. Multiplying its what? Reciprocal. So here, instead of divide by 4 over 3, I multiply 3 over 4. I think all of you know this one from quarter 3. Okay, minus 2t. Do you know how we get the integration? Okay, from negative 1 to 1. Just replace by the upper minus the value of the antiderivative at the lower. It will be what here? Replace, it will be 3 over 4 multiply 1 to power 4 over 3, and as you know, number 1, if you raise it to any exponent, it will be 1, minus 2 multiply 1 minus the other bracket, which is the value of this antiderivative at the lower. Here it will be 3 over 4 multiply negative 1 to power 4 over 3 minus 2 multiply negative 1. You can use your calculator. Okay, use your calculator, you can find the answer. Okay, wait, maybe I solve it in my paper. Mm. Okay, I have to solve it with you. This one, 3 over 4, 3 over 4 minus 2. It will be here 8 over 4. It will be negative 5 over 4, okay? Minus, if you substitute here, it will be negative 3 over 4. And here plus 2. It will be 8 over what? 4, it will be 5 over 4 minus 5 over 4. It will be 10, negative 10 over 4. Okay, in the simplest form, it will be negative 5 over 2, and you can use a calculator to find the answer, and you can check the answer is that right or wrong. Okay, let's solve the next one. I think it is so easy. Solve number 5. As you see, I know the integration of any number multiply function, it will be this number multiplies the integration of this function. Secant theta, tan theta, its integration, I know it is what? Secant theta. It will be 4 multiply secant theta. Because the derivative of secant theta give you this one. To make sure from your answer here, negative pi over 3 to pi over 3. Miss, how to substitute here secant theta? I know sec or secant theta, it is 1 over cosine because it is a reciprocal function of what? Cosine function. It will be here 4 multiply cosine, sorry, 1 over cosine multiply, wait. Mhm. Okay. لا done. Some of you can take this one 4. It will be 4 multiply the definite integral from negative pi over 3 to pi over 3. Another way to be easy, secant theta tan theta with respect to what? Theta. Okay, it will be, I can take this number 4 outside the integrate, this one to be easy for you. But no, oh my God, wait. But it is not wrong to keep it inside, but to make the calculation easy for you, but no problem to keep it inside. So it will be 4 outside here. If you replace here, but I in the calculator I don't have secant, but I know it is 1 over cosine what? Pi over 3 minus 1 over cosine negative pi over 3. From where we get this one? Because I know secant is what? Secant x, it is secant theta, it is 1 over cosine. To find the value of secant at any value, I have to write 1 over cosine, the value of this angle. It will be what here? It is 60. It will be half. Okay, multiply 4, sorry. 4 multiply half. Here it is half minus half. Wait. Okay, but forgive me, here it means 1 over. It means there is a reciprocal. So it will be here 2 reciprocal or 1 over half. It will be what? Wait. It will be 2 minus 2. So the answer, it will be 0. You can use your calculator to make sure from my answer. Okay. Okay, wait a minute. Okay, let's solve. Oh, wait a minute. Sorry. Okay, for this part, it is so trivial. As I told you before, to find the area of the shaded region, as you know, I use what? The integration. I use the integration. If the shape of the shaded region in the shape of one of the geometric figure, we can apply the geometric formula to find the area of this one. In this case, as you see in problem number 1, we can use any one of the two ways. Way 1, since it the given or the shaded region in one of geometric figure, we apply the geometric formula. It will be the length multiply with here 4 multiply 5, so the area, it will be 4 multiply 5, it will be 20 squared unit. Squared what? Unit. For way number 2, because some function, some region or some given region, it is not in the form of geometric figure that we have geometric formula to find its area. We can use way 2 in this case. How to find the area? It will be the integration of the given function, which is here 5, with respect to x. From we use the definite integral from what? The vertical line here 0 to the vertical line what? 4. Okay, to find it here it will be from 0 to 4. Then apply the fundamental what? Theorem, which is what? Find the integration of this function, which will be 5x. Then from 0 to 4, okay, it will be 5 replaced by the upper limit, 5 multiply 4 minus 5 multiply 0, it will be 20. Here the answer be the same as in way 1. If you use any way, the answer must be the same. Let's solve the last one, then the rest will be homework. Okay, um, any one of them we can solve. Last one, any problem by the same way. Look here to solve this one, to find the area of this shaded region, but it is not regular or it is not in the shape of geometric figure. In this case, we will apply fundamental theorem. I don't have another way. So it will be what? Integration from what vertical line here? 0 to this vertical line, which is what? Pi. From 0 to pi. Okay, the integration of this function. So to find the area by using what? Definite integral of what? The given function from the vertical line here 0 to pi. It will be x squared over 2. The integration of this one minus cosine x from 0 to pi. Okay, replace by in the integration of the function minus this one. So I'm sorry, I'll continue here the answer here. Okay, area, it will be what? pi square over 2 minus cosine pi minus 0 square over 2 minus cosine 0. Okay, it will be, I think, pi square over 2. This one negative, it will be plus 1. Minus, and this one, it will be negative 1. It will be plus 1. It will be pi square over 2 plus 2. Okay, thank you and for joining the session, and don't forget to solve the rest by the same way. Bye bye.